Question 16.15, what is the pH of a 0.65 molar solution of pyridine, given that the Kb for pyridine is 1.7 times 10 to the minus 9? So there's multiple ways we could answer this question. We could do several different rounds of calculations to get to the answer, so I'm just going to present one of those ways. But the first, where I would start, is we're given the Kb of pyridine. Pyridine is a base, so let's think about what that reaction would be. What does that Kb represent? So it represents pyridine acting like a base. So we want to take a proton, we want to accept a proton, so it's going to react with water to form a pyridinium ion. So it's going to pick up a proton, and I'm going to write it like this because the proton goes on the nitrogen, and now I'll have a positive charge on the nitrogen. And we took that proton from water, so we're left with hydroxide. And so to put in our phases, yeah, our water is a liquid, and we'll say our pyridine is an aqueous solution. So there's our expression for pyridine acting like a base. It's going to take a proton from water, forming our pyridinium ion and the counterion hydroxide. So that Kb, how we would write that Kb, it's products over reactants, right? So it would be the concentration of pyridinium times the concentration of hydroxide all over our initial concentration of pyridine. And from our Kb, we know Kb, and because this is a weak base, right, our Kb is very small. Because it's a weak base, we can basically assume that our initial concentration of pyridine, 0.65 molar, is also equal to our equilibrium expression. So we're looking for pH, right? We don't see anything in our expression for hydronium ion, but we do see an expression for hydroxide. So from our Kb and our initial concentration of pyridine, we should be able to find our concentration of hydroxide. Once we find that, we can then find our pH in a few steps. So the other thing to look at is, right, because one pyridine reacts with one water to form one pyridinium and one hydroxide, the pyridine and hydroxide are generated in equal concentrations. So if we call pyridine X, we could call our hydroxide also X. So now let's plug in the values that we have for our Kb expression. 1.79 times 10 to the minus 9 equals our concentration of pyridinium is X, our concentration of hydroxide is X, and our initial concentration is 0.65 molar. So we can multiply both sides by 0.65, and we're going to multiply this side by the 0.65. And it's going to cancel out, and we're going to multiply these two together to get x squared. So we can get x squared equals 1.105 times 10 to the negative 9. Now we're looking for x, so we can get that by taking the square root of both sides. So x would equal the square root of 1.105 times 10 to the minus 9. And x equals 3.32 times 10 to the minus 5. Now let's remember what X was. X was pyridinium and hydroxide. So that X equals the concentration of hydroxide and pyridinium, but it's really just the hydroxide we're interested in. And so now we know the concentration of hydroxide. Again, there's one or two ways we can calculate this, and I'm just going to show you one of the multiple ways, so don't be alarmed if you found the answer going a different route. We know that POH equals the negative log of hydroxide concentration, and we just found that hydroxide concentration. So I'm going to say POH equals the negative log of 3.32 times 10 to the minus 5. Take the negative log of that, and POH, we can find the POH to equal 4.48. And now next, we also know that pH plus POH equals 14. Well, we just solved for POH, so now we can solve for pH. So pH would equal 14 minus POH. So pH equals 14 minus 4.48. pH equals, what do we get? 9.52. So it took a couple steps, but we were able to finally determine the pH of this concentration of a solution of pyridine. And like I said, we could have gone a different route, just as easily. We know the relationship between Ka and Kb and Kw. We could have gone that route to find Ka and taken a different approach. Or, let's see, down here, we know hydronium times hydroxide also equals our Kw. We could have taken that approach to find hydronium concentration, but this is the approach that I took to get to the final answer. So hopefully that works or helps you out with this equation. But the important thing is to know our expression for this. So pyridine reacting with water forms pyridinium. It's acting like a base because we're given Kb. So we form the pyridinium and the hydroxide.